Right, video about types of erosion. So let's go back a bit of a stage to our long profile that we were looking at last session. So we said that if we cut a river from its source up here to its mouth lengthways and kind of mapped it on a diagram, it looks a little bit like this, with our upper course, our very steep parts, very sort of narrow river. Our middle course, where it gets a bit wider, it's starting to bend and meander, and then our lower course where we've got a really wide river and very flat land. And we drew from our long profile some cross sections of what our river would look like as well, so hopefully you've got something like that in your notes. Now, we didn't really talk about erosion at the time because I wanted to leave it till now. So with these different sections, our upper, middle and lower, we tend to find different types of erosion. So we start off in the upper parts of our river near the source with a lot of vertical erosion. So most of our erosive energy is attempting to erode downwards. That's for a few reasons. One, you've got to remember water is very lazy. It will take the path of least resistance and it wants to get, so bear with me. Go with it nicely. Sorry. It will take the path of least resistance and it will try and get to sea level as quickly as it can. Now, if the water's all the way up here, the quickest way to get down to the sea level is to try and go downwards as fast as it can. So it concentrates all of its energy trying to work its way downwards. Essentially, it's got more potential energy because of the force of gravity. So the force of gravity acting on the water molecules here is far greater than the gravity acting on the particles down here because it's far steeper. So those particles with more potential energy will try to erode vertically more in the upper courses of the river. That's why we tend to find these really steep-sided valleys with tiny little rivers in the bottom, because they're not concentrating on getting any wider or any fatter or any bigger, they're just concentrating on going downwards. So you end up with this nice V shape with a tiny little river right in the bottom. As we go further down, they lose some of their potential energy because the land becomes less steep and flatter. And all of a sudden, they start to use some more of their energy eroding what we call laterally or sideways or horizontally, whatever you want to call it. So as we go further down the courses, our river will get wider because less of the energy now is concentrated on going downwards and more of the energy is starting to concentrate itself on what we call lateral erosion, so eroding the riverbanks on either side of the river. And again, as we go down to the lower course of the river, it's lost most of its potential energy. There's hardly any sort of gravitational forces acting on those water molecules anymore. There's very tiny amount actually pulling it downwards, and most of the energy is concentrated on that lateral erosion, trying to erode the riverbanks either side. There's also a greater force of water as we're going further down. So our tiny piddly little stream all the way up here hasn't got much force. It doesn't travel in a way as fast and with as much force as when you get down here too. So there are other reasons why there is more lateral erosion, but the lack of gravitational energy and potential energy acting downwards is one thing we lose as we come down this long profile. Hope that helps. You need to just go and write a little definition of vertical erosion and lateral erosion, and there are some questions to answer on slide 27 and the answers are on slide 28, so have a go at those next.